Hi everyone, I'm Lorenzo Piarulli. I'm a PhD student at Sapienza University of Rome, and today I will briefly introduce the work that I will present at ISC 26. The work is characterizing the impact of congestion in modern HPC interconnects. First of all, I want to thank all the researchers that work with us for this analysis that are from Enea, OEHI, Huawei, and Chineka. Now let's move on to the analysis. We decided to conduct this analysis because on a modern supercomputer, we have many users that execute different applications on a shared environment. So we know that computing is growing really faster and that the network is not capable to keep up. We know that this type of environment are shared between users and between applications that are running HPC simulations or AI training using collectives. And we know that this type of sharing and interaction between users can degrade the performance because we can have congestion and link saturation. To conduct this analysis, we implemented two types of congestion, the steady and the bursty. Both of them are implemented using collectives. So the steady one is a collective that is executed continuously and is killed only when the victim has finished. Instead, the bursty is a collective that is interleaved between pauses, as we can see from the image. So this type of analysis has been conducted on 5 production fabrics. We have used InfiniBand EDR, HDR, NDR, Slingshot, and NSLB Ethernet. These type of congestion are implemented using two type of collectives, hole-to-hole to generate intermediate congestion and incast to generate edge congestion. We have been able to scale up this analysis to 256 nodes on real production systems that were Leonardo, Crisco 8, and Lumi. This is one result of our analysis. You can find many of them in the paper, in the full paper. So this result has been conducted on 64 nodes on Crisco 8, Leonardo, and Lumi. As we can see, the problem is mainly related to the incast congestion, that is the bottom line. In fact, as we can see in the bottom line, we have a lot of red boxes that shows us that the degradation of the performance is really huge. This type of problem is mainly related to Crisco 8 and Leonardo. In fact, Lumi is capable to handle this type of situation, probably for the synergy that he has with the fabric and the topology. So what we can understand from this presentation is the fact that despite the progresses, congestion is still an issue. In fact, incast is still problematic because it generates a really strong edge congestion, and also burst traffic expose many limits, specifically if the bursts are really, really short. So what we can understand is the fact that next generation needs better open congestion control and load balancing techniques, not just faster links. What we hope is the fact that Ultra Ethernet could be a step in that direction. If you want to talk to me, these are my contacts, and in the QR code you can find the full paper. Thank you.